If not, just let's sketch this together. Is two graphs, sine x and cosine x. Okay, sine x and cosine x. So I'll just draw this within one period. 2 periods too large. Okay, just between 0 and 2 pi to sketch this. Okay, and 1, 2, 3, 4, 5, 6, 7, 8. Okay, here is 2 pi, here is pi, and then each one is pi on 4. Okay, for sine x, I'll use a blue graph. Let's say here is 1, here is -1. Sine will start at 0. At pi over 2, it will go to 1. 1. Pi will back to 0. 3 pi over 2 will be -1, and 2 pi is 0. So you will have this graph for sine. Okay, the blue one is sine x. Okay, cosine x, I will use red. Okay, I will use red. So cosine x will start here. At here, I'll go to 0 and -1, 0 and 1. Pass through this point and pass through this point. Oh. Okay, so this graph will be okay, that's the shape of the cosine graph. Okay, so where I want to find what I want to find is pi over 4 and 5 pi over 4. So if you know that at pi over 4, they are just equal. So this point is pi over 4. This point should be 5 pi over 4 because sine pi over 4 equals to root 2 over 2 and cosine pi over 4 is root 2 over 2 as well. And sine 5 pi over 4, that equals to minus sine pi over 4. Okay, because that's 5 pi over 4, reference angle is pi over 4, and that's in the tangent quadrant, that's why it's negative. And you have cosine 5 pi over 4, same negative cosine pi over 4, and they have the same value as well. So at pi over 4 and cosine 5 pi over 4, they are equal. So you want the area enclosed by this graph. Okay, you want the area enclosed by this graph, by those two graphs in between that range. So basically, you're trying to find this area. Okay, trying to find this area. As I said, doesn't matter the graph is above x-axis or below x-axis. What you need to think about is which one is higher. Okay, in this case, the sine graph is above the cosine graph. From pi over 4 to 5 pi over 4, and the sine x will subtract the cosine x and dx. So, okay, what's the antiderivative for sine x? Negative cos x. And what's the derivative for cosine x? Sine x. Okay, cosine straight back to sine. And then I'll start pi over 4 and 5 pi over 4. So what you have is minus cosine 5 pi over 4 minus sine 5 pi over 4. Okay, they are the first substitution. Minus bracket minus cosine pi over 4 subtract sine pi over 4. Okay, what you have here is root 2 over 2. And this is plus root 2 over 2. Because both cosine 5 pi over 2 and 5 pi over 4 and sine 5 pi over 4, they are negative root 2 over 2. You have a negative sign in the front that become positive root 2 over 2. And subtract, bracket, okay, minus, that's a cosine pi over 4 is root 2 over 2, minus that. Okay, that is actually root 2 over 2 times by 4. Plus, 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 and you have a 2 root 2 as the area enclosed by that. Okay, just some calculation thing. Minus and minus, plus, plus, and this will become a plus sign. This one and this one will become a plus sign. So it's 4 root 2 over 2 add together. So it's 2 root 2. Okay, it's 2 root 2. Okay, next one. Example 4. Sketch the graph y equals to negative e to the power of x. The line y equals to 3x, x equals to negative 2, and x equals to negative 1. Indicate the region bound by these equations. There are 4 equations. Okay, and hence find the area indicated by this region. So I want to sketch y, x, e to the power of negative x, have y equals to 0 as the asymptotes. Okay, y equals to 0, I have 0 minus 1. Okay, 0 minus 1. Before the graph looks like that. Now it will reflect it by the x-axis. Then the graph will look like this. Okay, get reflected. So your graph should look like this. And you want to sketch 3x as well. So you have 0, 0 here. Let's say we have negative 1 and negative 3. It's this point here. So, okay, this is a linear y equals to 3x. And I need to sketch y equals to negative 1. Here's y, well, it's not parallel. Okay, that's x equals to negative 1. And I want x equals to negative 2. Okay, here is negative 2. Okay, this is x equals to negative 2. Okay, x equals to negative 1 and x equals to negative 2. And 3x and this exponential graph. Okay, where is the area bound by those 4 graphs? In which quadrant? Just look at this graph. Where is the region bound by 4 line? Quadrant 3. Okay, is this area here? Okay, is this area here? This region starts from negative 2, finishes at minus 1. And the exponential graph is above the linear. The exponential graph is above the linear. So basically you want to integral from negative 2 to negative 1 and e to the power of minus x in the front, and you, not there. It's minus e to the power of x like that, and you will subtract 3x, dx. Okay, exponential is here. Okay, this region starts from negative 2, finishes x equals to negative 1. That's why you have upper and limit, lower limit like that. 2 equations subtract each other. You have this equation. So the integral of that e to the power of x integral is still e to the power of x minus 3 over 2 x to the power of 2. Put minus 2 and minus 1 in. We put minus 1, that's this, minus 3 over 2. Minus, put negative 2 in, minus 2 times 2 is 4. Okay, 4 minus 6. This is e1 over e minus 3 over 2 plus 1 over e to the power of 2 plus 6. Nine over 2, 6. 12 minus 3 is 9, so 9 over 2 plus 1 minus e over e to the power of 2, or you can just separately write those two. No, that's also correct. Okay. Any question about this? Well, like if you have a calculator, what you can do is just basically negative 2 to negative 1. Absolute value, I don't care which in the front. I can say 3x in the front. Okay, 3x minus bracket negative e to the power of x and dx, absolute value. E to the power of x and dx. I can just type that into the calculator and you will have your answer. Alright. First question, I will skip the first one. It's exactly the same as the previous one. You will practice that by yourself. Exactly the same. Just change the area. Well, the area changed from negative 2. Okay, you can just see the graph on the top. Okay, e to the power of x like that and 3x like that. If you have the line negative 1.5 to 1.5, the area will be, well, like just roughly sketch the graph like this. And if you do this, you have this region and this region. So you need to talk about that separately and you need to find the intersection between that by using CAS. But this question will be CAS question. Why is this CAS question? It says correct to 2 decimal places. It must be a CAS question. So if it's CAS active, we need to do is just negative 3 over 2 to 3 over 2, absolute sign, 3x plus e to the power of x, absolute dx. Directly put that into calculator and work that out. Even though it's exactly the same, but if you do hand approach, you need to find the intersection first. But like, it's hard to find intersection. You can't really solve for that by like hand. So it's a CAS question, and also state that correct to 2 decimal places. Directly put that into the calculator and the calculator will give you a correct value. You don't need to worry about who is on top, who is bottom. Absolute sign. What's wrong with that table? You can, no, you subtract them. That's a minus negative e to the power of x. That's a subtraction. Or you can do that. You can use minus e to the power of x minus 3x. Okay, both correct. Don't need to worry about which on top. Okay, next one is very, very, very important. Okay, how important is this? To find the area of the shade region in the diagram. Okay, it's a multiple choice question. 4 different students proposed following calculations. There are 4 calculations here. Okay, there are 4 calculations here. And ask you which one is correct. Okay, ask you which one is correct. This question is very interesting. Okay, Okay, let me know what do you think. Okay, let's have a look at the normal way. What you can do, just let me know what you're trying to do to find the area, the shading area. What you can see is a rectangle. If you use that rectangle to subtract the white area, that will give you the shading area. Is that correct? Well, I have e to the power of 2x, and then I have 1 and e2. So this rectangle equals to 1 times e to the power of 2. This rectangle equals to 1 times e to the power of 2. And I want to know the area under the curve. I want to know the area under the curve. Where's my curve? Okay. So I want to know this area. So it's just an integral from 0 to 1. E to the power of 2x dx. That's this white area. Okay, that's this area here. So what you can do is use that to subtract that. We'll have this option here. That's definitely correct. Okay, I can pick up the first one, which number 2 is correct. Well, I can only say E is incorrect. Well, number 1 definitely not correct, because 0 to 1 e to the power of 2x is only the white area, it's not the shading area. So anything include 1 will not be correct. So I can just say C can't be the correct answer as well. And let's have a look at 3. Well, I don't really know what 3 is look like, but I want to tell you a really important thing is, I just have a piece of paper. Okay, that's good enough. Okay, I'm not sure if this will work. This works or not. I'll just sketch a graph on this paper, and I will show you the other way. Okay, that's y-axis, that's x-axis, and I have a graph. Looks like this. And I want this region. Okay, I want this region. And I have a rectangle here. Okay, so not sure if you can see this. You see this way, okay? So that's the y-axis, that's the x-axis. The area bound under the curve will be this white area here if you use integral to calculate. Okay, like from here to here, this part. Okay, if we flip it to see it this direction, okay, that's the x-axis, that's the y-axis now, right? I can treat x-axis as y-axis, and I can treat x-axis as y-axis. I just totally flip it. What's the graph look like? Okay, that's my y-axis, positive direction. That's my x-axis now, positive direction. I flip my paper. Can you see the shape of the graph? Can you see that? Okay, that graph becomes x equals to how many y? Okay, x equals to how many y? And then this part directly becomes the area bound by the curve, the area under the graph. Can you see that? That becomes, okay, from this point to this point. Okay, what are those 2 points? What are those 2 points? Let's flip back. Remember those 2 points, okay? Let's just turn back. It's those 2 values. Okay, it's those 2 values. What are they? This is 0, 1. So that is 1. That is 0 e to the power of 2, because that's 1. That's e to the power of 2. So that's e to the power of 2. So let's just flip it back. So you just integral this function 1 to e to the power of 2. But I need to change this function into x equals to something, because your axis becomes your y-axis. I need to change x equals to blah blah. So what I need to do now is, okay, I flip this graph to the other side, and then 2x become log e y, and x will becomes a half log EY. Okay, I just changed my x-axis into y-axis. Then this graph is just a half log EY. Okay, this graph is a half log EY. And I will integrate that graph according to dy. Before we dx, okay, we dx it. But like not y is my x-axis, I will dy it. So I will integrate this graph. A half log EY, I will dy this graph. Where is that? Is that from this point, which is 1 before, and then finish this point, which is e to the power of 2. So it's 1 e to the power of 2. That will directly give you this area under the curve. I'm going to just let you see this graph again. Or if you can't see it now, like later you can go back home, find the paper, just draw the graph and fit it, and you can see where is it. Well, like normally teacher will teach, let's say, oh, you look at this direction. Well, from this side to this side, and that's the area and the curve. You can't really see it. You need to totally flip this paper, and you can see the shape. Okay, it's not really see from this to this. It's this side. Okay, it's the back. It's the back. The area under the curve is talking about the back. That's your new y-axis. That's your new x-axis. Okay, it's all should point into the positive direction. So this answer will be correct as well. Okay, this answer will be correct. Well, even though it says dy, we have dy, they have dx, doesn't matter. Okay, you change your variable dx to dy, it's the same. You have the same results. They're exactly the same. I can even say that's dA. I can even say that's dA. So this will be correct as well. Then this answer D is correct. D is correct. Okay, and I want to go through a really important question with you. Page 19, like add one more question here. Okay, I'm not going to talk about that. Question 4. Really important, please write this on the paper. Okay, I forgot to type this question. It should directly connect with this question here. Okay, I have log EX graph. This is y equals to log EX. This is y equals to log EX. Okay, and the next thing we talk about, okay, what I want you to do is, I want this area. I want to know this area, and I'll tell you that's approximately 5. Okay, that's 5. I want to know this area. You don't, like, the thing is, you don't have a calculator. Okay, this is a part 1 exam. You don't have your calculator. That's x equals to 0. I want to know the shade region. Okay, the area of the shade region. Alright. You may think, okay, easy question. Area under the curve, directly bound with x-axis, nothing wrong. So the equation will be from 0 to 5, from 1 to 5. That intercept will be 1. 1 to 5, log EX, dx. Well, if you have calculator, easy, perfect. I can put that into calculator, find out the answer. But if no calculator, no CAS, what's the integral of log EX? Do you know that? Do you know that? No. Well, like, you can work it out like later after you learn more, but like by year 12 we don't have this rule. We don't know the integral for log EX. We only have derivatives for log EX. So I can't do it. Well, even though it's a correct representation, I can't do it. So what I can do is, I can use the rectangle. So here is 5. Here will be log E5. Okay, here will be log E5. I can use the rectangle. So 5, 0 to 5. Okay, 0 to 5, that's a 5 times log E5. To subtract the white area. Okay, to subtract the white area, I can use this rectangle to subtract this part. Why I'm trying to subtract this part? I need to waste another piece of paper. Okay, so I'll just sketch this log function on it. Okay, what I'm trying to find now. Okay, here is 5, here is 1, here is 0, here is 5 log E5. Okay, so what I'm trying to find now is the white area. I will just on my paper shade this white region. Okay, shade this white region. Okay, your y-axis is here, that's your y, that's your x-axis. Okay, again, I want to find this area. This area is not the area under the curve. Okay, it's not the area under the curve, it's just some side area. So what I want to do is again switch your paper. Can you see a shade? Can you see a shade? That's your x-axis, that's your curve. That's the area under the curve. Okay, that's the area under the curve. Okay, if you put it that way. So your x-axis becomes your y-axis. And this area becomes the correct area I can directly calculate this. Okay, this area becomes the area I can directly calculate this. And I can, well, why I do this, why I flip it? Because if you make x to be the subject, the function will become exponential function. And I know the integral for exponential function. So, okay, what's the, where it starts from? It's this shaped region. Can you see it starts from 0? Okay. That's the x-axis, that's the y-axis, here is 0. I finish it here. That is log E5. That's log E5. I finish here. So what I can do is, I can find x equals to e to the power of y. Okay, you just look at the other way. This function will look like this. This is called e to the power of y. E to the power of y. And I will integral e to the power of y dy from 0 to log E5. From 0, okay, 0 is here, log E5 is here. Okay, go this way. And I'll use the white area to subtract that. So it's 5 log E5. Use the rectangle to subtract this. That will give me the shading region. That's the white area, and subtract them, they are the correct region. So what I will have is 5 log E5 minus, well, EY is still EY, 0 log E5. And that's 5 log E5. Subtract. Okay, what I'm trying to subtract is e to the power of log E5, which is 5, minus log E0, which is 1. So that equals to 5 log E5 minus 1, minus 4, no, minus 1, minus 4. Well, when you can't understand anything, just go back home and draw it and see it from the back. And it will make a lot of sense. Okay, go up a little bit, go to part 3. A part of the graph of this is this function here. Okay, x squared minus 4. Okay, x squared minus 4. The area of the region marked A is the same as the area of the region marked B. What is the exact value of A? Okay, I want from 0 to A. this area is the same as this area. Okay, this area is the same as this area. This graph is x squared minus 4. Is it? Yeah, x squared minus 4. So here must be 2. Here must be 2. X-intercept is 2. So, but 0 to 2 is the negative area. So negative of 0 to 2 of x squared minus 4x dx will equals to 2 to a is positive x squared minus 4 dx. They are equivalent. They say area A and area B are the same. But when you write about area A, it should be negative of this integral because it's below the x-axis. So I have minus a third x cubed minus 4x 0 to 2 equals to a third x cubed minus 4x. You sub 2 to a. Okay, you have, okay, very careful. There's a negative in the front, which is negative the whole thing. So you will put a square bracket here and you sub 2 in. It's 8 over 3 minus 8. Subtract 0 minus 0. Finish the bracket. It's like that. And that equals to 1 over 3a to the power of 3 minus 4a. That's the first equation. Minus bracket 8 over 3 minus 8. That's the second equation. So what you have is minus 8 over 3 plus 8 on the side equals to a third a cubed minus 4a minus 8 over 3 plus 8. They can all cancel and that side become a 0. So a third a bracket a squared minus 12 equals to 0. Well, a equals to 0 or a equals to plus minus root 12. A equals to plus minus 2 root 2. Okay, 3 solutions, but obviously a is positive. I think it says, it's not really says, but like a is in the positive side. So a is positive. Okay, a is positive. So a is positive. I will have this root 12. Root 12. Okay. That's just a solving question. Okay, that's a solving question. Or you can use your CAS to solve it directly. Well, how we can do that? Menu 3.1. Okay, minus integral from 0 to 2. I have x squared minus 4 dx. That is equals to integral 2 to a and x squared minus 4 dx. We solve for that, comma x, and we can control equal, have this bar here, say a greater than 0. Wait, solve for a. Something wrong. Not solving for x, solving for a. Thank you. Yeah, 2 root 3. Okay, 2 root 3. It's quicker to use CAS to do it. Okay, it's quicker. So we can directly use CAS to do it. If it's multiple choice, then it will be a part 2 exam. Then we can use CAS. How many pages I have left? That's page 20. I have 9 pages. Well, I want to talk about one thing before I haven't really talked about it. Just go to the very beginning when we talk about the antiderivatives, just find some space, like find anywhere, like after example 1, just write one more question for me. Well, what I want to do is to integral and given x is less than a third. No, greater than a third. X is greater than a third. Okay, so that's what I'll give to you. So, what's this antiderivative will be? What's the integral for that? Log. Okay, if it's a log function, that's the gx. That's the gx. And then g dash x will be -3. G dash x will be -3. But I can't just ignore this 2. I still have this 2 outside, and I will divide -3 down. Okay, I can't just times the -3. So I need to divide by this -3 and dx. So what I will have is -2/3 log e. Remember I said there needs to be an absolute sign around it. It's absolute minus 3x plus 1. Minus 3x plus 1. Okay, like if there's no domain given, like just say x can be anything, my answer will stay like this. But now it says x is greater than a third. Just let me know, when you see this absolute sign, what you really cares about. Like when that will have a change, when the thing won't change. When there's like negative inside, it will change. When it's positive inside, it won't change. So the thing I have interest is, do I have a positive number inside or do I have a negative number inside? Okay, that's the thing I more cares about. The domain gives you is x greater than a third. When x greater than a third, have a think what the inside will be, negative or positive? Well, I should be able to do this. It's a linear, minus 3x plus 1 time, like x is greater than a third. Just have a calculate, like have a think about it. It's negative. Because let's say we just can solve that normally, like we solve that is negative. Minus 3x will less than minus 1 and x will be greater than a third. So x greater than a third will give you that function negative. Okay, give you negative. So if that's negative, okay, what you can do to -2, what that will equals to? 2, right? Right? Yes, that is 2, right? Okay, everyone know that? Absolute, we put in the modular sign, that will come out with a positive number. Well, how -2 can become 2? What kind of calculation you can do to this -2 to make it to 2? -2. Do something to -2, make it to +2. What you can do? Not +4, don't plus it. Times something. Times -1. Okay? Times -1. Okay, so -2 absolute will be -1 times by -2 will give you the positive. Well, let's say we have a -4. What you can do? Don't tell me +8. Okay, times -1. For this negative number, the negative will turn to positive, and you only have the how large is that? Okay, the size of it. So any negative number, you times -1 on that to turn that into a positive number and get rid of the absolute sign. Well, you don't really like the absolute sign. The absolute sign doesn't give you any indication. So you need to expand first, get out of the absolute value first, and then we can keep calculation. So now what you know is when x is greater than a third, the inside value is smaller than 0. And now I want to get out of this modular sign. What I will do is, okay, -1 times by this number. Because I already know this is a negative number, and I will negative that again to make it a positive. So -1 times this is positive, right? Is positive. You can only put positive number into log. So therefore, that's -2/3 log e. Okay, 3x minus 1 plus c. That will be your final answer. Well, when the domain is given, it's not good enough that you stay here, because you can't actually get your number out of the absolute value. That will change to this. 3x minus 1. Test 3x minus 1. We put a third in. X greater than a third. That number is greater than 1. Greater than 0, which is good. Okay, which is good. So that's your final answer. That's your final answer. Very important. This part is very important. How change from this to this. Okay, very important. Okay. Just want to do a little bit more for the graphing. We have learned this before. I'll just talk about a little bit more about it. I just have 2 more lessons next week. I'm afraid I can't finish the rest of the page. I have 9 more pages. I normally won't use the last lesson, like where we have like some celebration end of semester. And Thursday you don't have class, I think. And Monday and Wednesday is the only 2 lessons. And Monday is 70 minutes and Wednesday is only 50. So I have 2 hours. I'm afraid I can't finish all. I just have 1 more exercise, but it's 9 pages. Okay, I just want to do the graph bit with you. So remember, before when I give you fx, I'll ask you to sketch f dash x for me, right? When I have fx, I'll ask you to sketch f dash x for me. Now is when you have f dash x, I want you to sketch fx for me. Just another way, going back to sketch it. Well, let's say this question. The graphs of y equals to f dash x and y equals to fx are shown here. And I want you to find the root for f dash x and fx. Well, that question is easy. Okay, that question is easy. So your well, it's easy in a way. So because your f dash x is just equals to minus x. It passed through 0, 0, and it passed through 1, negative 1. So f dash x is minus x. But what you can see here, your fx function only have 1 point given, not all of it. Okay, not 3 points. So you only have 1 point given. What you can do is fx equals to the integral of minus x dx. That is minus a half x squared plus c. Minus half squared plus c. But what you know is sub 0,4 into this function because 1 point is given, which is 0 and 4. You know that point. So 4 will equals to c. So your fx is minus a half x squared plus 4. Minus a half x squared plus 4. Okay, you need to use the rule to help you a little bit. Even though you know that's a quadratic, you only have 1 point given. You can't really work out the solution, the equation, because you're not sure with the x-intercept. So you need this function to help you. Linear, you definitely know what is the linear equation. Integral of that, substitute a point. Okay, number 6. Sketch the graph of the antiderivative of the function shown, given that it passed through the origin. Given that it passed through the origin. Well, I just want to sketch the shape of the graph. Not saying like it's accurate. Okay, you won't really get an accurate graph. You won't really get an accurate graph. Even though like this graph gives me -2 and 1 as my intercept for f dash x, but I don't know another point. I can't work out the exact equation for this quadratic. I can't find integral then. Well, I don't know what is it. I just roughly know what is it, but I don't know the exact equation. So your antiderivative graph will not be an exact value, exact graph. Okay, I'll just teach you here. How do we sketch by using f dash x function? Go back to fx function. Do you remember the table we did before? Okay, at how many points that f dash x equals to 0? How many points f dash x equals to 0? 2, -2 and -1. So I will set up this table. Remember that table, you have x value, f dash x value, and graph. Have graph. So first one always empty. Second one is the first number can make the derivative equals to 0. So what I should put inside here? The first x value can make the derivative become 0. Left hand side. So I will have -2 here. Okay, the next one will still be empty. And the next one will be the next stationary points. What is that? What I should put in the box? Remember, I want f dash x equals to 0. Which 2 points can make f dash x equals to 0? -2 and 1. So this point will be 1. And I will have the last box empty. So those 2 parts, your derivative is 0. Okay, to the left of -2. To the left of -2. What is the gradient? Is that positive gradient or negative gradient? That's your f dash x graph. Is that a positive gradient or negative gradient? To the point, to the left of -2. Negative. Your graph is below the x-axis. It's negative. Okay, it's not positive. It's not that you are not looking at the gradient of this graph. That is already the f dash x graph. It's the gradient graph. Like I said, -3. Your gradient is negative. So you have negative here. In between 0, like -2 to 1. Your gradient graph is above the x-axis. So you have a positive. You have a positive. And to the right of 1, your graph is below the x-axis and you will have negative. Okay, that's the gradient at the corresponding place. What the graph looks like? -0, +0, and negative. That's the shape of the graph. So the shape of the graph is like that. That's the shape of the graph. What you have this point, it should be -2 something. This point should be 1 something. So your 0, it passed through 0, 0. Well, let's just say that's roughly the graph. And I have 0. Where's my 0? My 0, 0 should be here. Roughly shape. Oh, no, I want this. Okay, approximately the graph looks like that. You don't know the exact value. Okay, you don't know the exact value. You can be sketch it a little bit differently compared to this, but this point is definitely -2 and it's the minimum turning point. This point is definitely 1 something and it's the maximum point. Any graph definitely will pass through 0, 0 because it's given in the question, and that will be roughly the shape of the graph. Well, you can stretch that longer, and this is lower like that. It's also correct. You won't know this point and this point. You won't know this point and this point. It's not given in the question. So you can sketch it anywhere. Okay, you can sketch anywhere. So the most important thing is this negative shape of the graph. Second is the 2 turning point at the correct x place. Last, it passes through 0, 0. Anything else you can sketch like what you want. Okay, you can sketch whatever you like. Okay, I'll do one last example with you. Okay, last one. This is f dash x graph. Okay, this is f dash x graph. Sketch the graph of the antiderivative of the function shown, given that it passed through the origin again. So how many points you can see that gives you f dash x equals to 0? 2. -2 and 0 give you f dash x is 0. So what I will do is draw this table. I'm not sure if it's enough box. Have f dash x and the graph. First empty, second you have -2, next empty, the last one 0, and you have another box here. Okay, that 2 point give you gradient 0 and 0. So to the left of -2, you have negative gradient. In between 0 and 2, you still have negative gradient. It's still below the x-axis. After 0, you will have positive gradient, which is plus. Okay, is negative 0, -0, and positive. Okay, so what that shape looks like. That's a stationary point of inflection. And you have 0 here. Well, it's not. Okay. This stationary point of inflection must have coordinates -2 something. And here must be 0 something because it's the stationary point at 0. But you know that it must be 0, 0. It's given in the question. It passed through the origin. It passed through the origin. So you will have 0, 0 here. Therefore, the graph will look like that. The graph will look like that. Well, it can dilate a little bit. You can make the stationary point of inflection higher or lower. It doesn't matter. But you must have this shape of the graph. Okay, this is the x-axis and this is the y-axis. Can you see the graph is just this shape and then going up. So you have a minimum turning point, a point of inflection, and it passes through 0, 0. If you can sketch all of that out, your graph is correct. Okay, your graph is correct. Okay, so I want you to do example 8, example 9, and the next page, U-turn page. Okay, so you will do until page 23. Okay, page 23. So page 22, page 23, just complete that by yourself. Well, definitely try this question. Okay, definitely try this question, the U-turn question. Well, I want to find the antiderivative of that. Please try that one. Okay, please try that one. It's very important.